The center of the mind map for polar graphs was with the definition that a polar graph is two-dimensional coordinate system, and a limaçon has the equation of either r equals a plus or minus b sine theta, or r equals a plus or minus b cosine theta. And the first graph, an inner loop, has the actual loop inside of the graph itself. So that's how you could tell the difference between that and a cardioid, which is more of a heart shape that has a dimple instead of the loop within it. And a cosine is on the x-axis while sine is on the y-axis. They're mathematically different because the formulas of the inner loop and the cardioid, and as well as cosine being on the x and sine on the y. So the inner loop has the formula of a over b is less than 1, then it would be an inner loop as seen in the graph. While a cardioid is a over b equals 1, which would show in this graph as well. A and b determines what shape the graph will have. So like I said earlier, the ratio a over b is less than 1 or a over b is equal to 1. The difference of a and b gives the first x-intercepts for cosine, and the sum of a and b gives the second x-intercepts. As you can see right here, it would be giving the first y-intercept for the cardioid with a sine graph. The symmetry that sine has is pi over 2, so we would reflect this over the y-axis. And then the inner loop is polar axis symmetry, which you would reflect over the x-axis, and the formula for polar would be replacing theta with negative theta, and then you would get that. Moving on to the rose curve, they between the odd and even, so we have odd cosine and even sine. You could tell they're visually different because an odd amount of petals or an even amount of petals. And the odd amount has one symmetry point, and at least one of the curves is on the x-axis because it is cosine. And then the even sine graph is even between each x and y-axis because it is symmetrical through all three tests. Mathematically, they are different because of the n value given in the question. So here its n is odd, so we would go about that differently by using this as the amount of petals, whereas even we would do 2n to find the amount of petals. And the role of A is to determine the length of each petal. So A in this one is 2, and we would go to the second circle. N determines the amount of petals each group, so odd petals is n and even is 2n. Positive or negative A also determines whether or not the graph will be on the positive or negative axis for the first line that you graph. So this one, A is positive, so the first petal would be on the positive x-axis. The symmetry for the odd cosine is polar axis over the x because it is cosine, and sine is symmetrical in all three because it is even. So if we were to reflect it over x, y, and the origin, it would be symmetrical for all three. Moving on to the circles have a formula of either r equals a cosine theta or r equals a sine theta. These are visually different because of where the circle graph will be on the coordinate plane, whether it's cosine on the x-axis or sine on the y-axis. The role of A gives the diameter of the circle. So here it's the absolute value. So here A is 6, so we know that the diameter is 6, but since it's negative, it goes to the negative side of the coordinate plane. And then for sine, A is 2, which is positive, so it's on the positive side of the y-axis, and the diameter is 2. And then the radius is half of A, or the absolute value once again. So we would go from the x-axis, the center, so we go up 3 because half of 6 is 3, and then down to the negative 3 on the y-axis as well. And And the symmetry for the cosine has polar axis symmetry, which is over the x-axis. And then sine is pi over 2 because it is on the y-axis. So if we were to reflect on the y-axis, it would be symmetrical.